This video tutorial is all about atoms. In this video we're going to talk about several things. We're going to talk about atomic structure. We're also going to talk about protons, neutrons, and electrons. Where are they located and what are their characteristics? We're also going to talk about atomic number and mass number. Well, you have to ask yourself, what is an atom? Well, atoms make up matter. What is matter? Matter is simply anything that has the property of mass and volume. By volume I mean that takes up space. So you might ask yourself, what types of materials take up space? What types of materials have mass? How about air? You look at it, you can't see it. Does it have mass? Does it have volume? And the answer, of course, is yes. You know it has mass and it has volume because you're sitting at the bottom of a huge ocean of air, and you can feel the weight of the air pushing down on top of you. Literally, it keeps you from exploding. And that weight of air comes from the fact that gravity is pulling on the mass of those air particles, and that gives you air pressure. All matter is made of atoms. Elements, are they made of atoms? Absolutely yes, they're made of atoms. Air, we know now that air is made of atoms. How about you? Are you made of atoms? Absolutely, you're made of atoms. Everything you see and everything that you can touch in the universe is made of atoms. Atoms are made up of protons, neutrons, and electrons. It's also important to note that those protons, neutrons, and electrons are made up of even smaller particles. They're called quarks. But we're going to talk specifically about protons, neutrons, and electrons. Protons have a mass of 1 atomic mass unit, and each proton carries an electric charge of +1. Here's a proton. It's labeled with a P and a plus sign because it carries an electric charge of 1. All neutrons have a mass of 1 atomic mass unit, but they carry no electric charge. Here's a neutron. You notice it has no positive sign on it. It doesn't carry an electric charge. It does have a mass of 1, just like the proton does, but it doesn't carry an electric charge. All electrons have almost no mass. As a matter of fact, the mass of an electron is about 1/1832nd the mass of a proton. And each electron carries an electrical charge of -1. So you can see this electron that I've drawn here has a negative sign on it because it carries a negative electric charge. The two charged particles in an atom are the proton and the electron. Protons and neutrons are located in an extremely tiny, dense central core of an atom. It's called the nucleus. It's very tiny and very dense. If you could build a model atom to scale, you could make the nucleus the size of a grain of sand and set it in the middle of a football field. The first electron would be invisible and it would be at the goalpost. Atoms are mostly empty space. The mass of the atom is contained in a very tiny, dense central nucleus. That's where the protons and neutrons are. For instance, here's a nucleus. I've drawn some protons in red. You can see they're labeled with a P and a plus sign. And the neutrons in this nucleus I've drawn in blue, and they're labeled with an N. Now remember that the proton carries a positive electrical charge. The electrons orbit the nucleus in energy levels within an electron cloud that surrounds the nucleus. Here are some electrons. You'll notice, by the way, that there's 1 electron for every proton that's in the nucleus. Those electrons are moving so fast that if you could actually see the atom, they would appear as a blur that surrounded the atom, and they would create what's called an electron cloud. So here I'm showing you the electron cloud. So here is our model of the atom. It has a very tiny, dense nucleus containing protons, each with a positive charge and a mass of 1, neutrons with no charge and a mass of 1. And orbiting that nucleus are the electrons that have almost no mass, but each electron carries a negative charge of 1. They move so fast, they form a cloud around that nucleus. Let's talk about those electrons. Here we see our atom. We see the nucleus with the protons and neutrons. We see the electrons orbiting the nucleus within this electron cloud. Electrons have a magnetic polarity. That means, similar to the Earth or a bar magnet, they have a north and a south magnetic pole, and they also spin as they orbit the nucleus of the atom. These electrons spin on their axis, and the spin direction, whether it's clockwise or counterclockwise, depends on the magnetic polarity of the electron. So if we could look at one single electron, say this one here, we notice that it's spinning, in this case, in a counterclockwise direction. The north pole appears to be pointed up and the south pole appears to be pointed down. And I've drawn an arrow to represent the spin of the electron. This up arrow tells you that this electron is spinning in a counterclockwise direction, and that the north pole is upward. Well, let's look at another electron in this atom, this one down here, and we can see that this electron is spinning in a clockwise direction. The north pole is reversed here. It's pointing downward on the page, and it's represented by a downward arrow. So if I wanted to draw the spin representative of an electron, I can use either an up arrow or a down arrow. That tells you the polarity of the magnetic field and the spin of the electron. Here's our atom again. You see the nucleus with the protons and neutrons. You see the electrons orbiting that nucleus, and you see the electron cloud. In the ground state, that means the lowest energy configuration for this atom. In the ground state, atoms will have the same number of electrons as protons. 5 protons, 5 electrons. This is important because it cancels out the electric charge of the atom. In the ground state, the atom is electrically neutral. It has no net electrical charge. The charge is canceled out by the equal number of protons and electrons. Let's talk about an atomic number. Elements are made of atoms, and an element consists of only one kind of atom. For instance, a gold atom, a copper atom, oxygen atom, helium atom, they're all examples of elements. The atomic number of an atom determines what element you're dealing with. Every element has a specific number of protons in its nucleus. The atomic number of an element is determined by the number of protons in the nucleus. Every element has a different number of protons in its nucleus. Gold, copper, oxygen, helium, each one of those elements has a different number of protons in the nucleus. This atom has 5 protons in its nucleus. The atomic number of this atom is 5. If this atom represents an element, and it does, all atoms with the atomic number 5 are boron atoms. That's what makes this an atom of boron. It has 5 protons. It has an atomic number of 5. So the atomic number is the number of protons in the nucleus. And this atom has an atomic number of 5 because it has 5 protons in its nucleus. Helium does not have 5 protons in its nucleus. Only boron atoms have 5 protons. That's what makes it boron. The atomic number of the element boron is 5. Mass number. This atom has 2 protons and 2 neutrons in the nucleus. We know this is an atom of the element helium because the atomic number is 2. All helium atoms have 2 protons in their nucleus. And you'll also notice that this atom has 2 electrons. That cancels the electric charge. The overall electric charge of this atom is 0. It's neutral. 2 negative charges for the electrons, 2 positive charges for the protons. And by the way, the mass of the nucleus here is 4 mass units. So we know this is an atom of the element helium because the atomic number is 2. This atom of helium has a mass number of 4 because there are 4 mass particles in the nucleus. Since each proton and each neutron have a mass of 1 atomic mass unit, the mass number of this helium atom is 4. Do all helium atoms have a mass number of 4? No. While it's true that all helium atoms have an atomic number of 2, they don't all have a mass number of 4. Mass number can vary with the number of neutrons that are in the nucleus. This helium atom has 2 protons and 3 neutrons in the nucleus. It's still helium. We know this is an atom of the element helium because with 2 protons in the nucleus, the atomic number of the atom is 2. And the atomic number of helium is always 2. But this atom of helium has a mass number of 5. Why? Because there are 5 mass particles in the nucleus. And since each proton and each neutron have a mass of 1 atomic mass unit, the mass number of this helium atom is 5. Mass number is the sum total of the mass particles in the nucleus of any atom. This atom has 5 protons in the nucleus. The atomic number of this atom is 5. Remember, all atoms with the atomic number of 5 are boron atoms. But along with the 5 protons in the nucleus, there are also 4 neutrons. The total number of mass particles in the nucleus is 9. That's 5 protons and 4 neutrons. 5 plus 4 equals 9. The mass number of this boron atom is 9. Why? Because there are 9 mass particles in the nucleus. 5 protons and 4 neutrons. And that's what gives it a mass number of 9. Here's another atom. It has 3 neutrons, has 5 protons in its nucleus. The mass number of this boron atom is, you guessed it, 8. Why? Because there are 8 mass particles in the nucleus. Mass number is simply the sum total of the mass particles in the nucleus. It's still boron. It acts like boron. It looks like boron. It looks like every other boron atom because there are 5 protons in the nucleus. But the mass number of this boron atom, in this case, is 8. The only difference between the 2 boron atoms that we've seen here is mass number. Here we have 2 atoms. The isotopic symbol shows the element symbol. It shows the atomic number, and it also shows the mass number of the atom. The atomic number of the atom on the left-hand side is 5. The atomic number of the atom on the right hand side is 5. They're both boron atoms. Isotopes are atoms of the same element that have different mass numbers. The only difference between these two atoms is the mass number. The mass number of the atom on the left is 8. The mass number of the atom on the right is 9. Why do they have different mass numbers? Because they have different numbers of neutrons. Isotopes are atoms of the same element that have different mass numbers because they have different numbers of neutrons. They're still the same element. They only differ in mass number.